Hello, this is Concrete Path. Here is the first lecture for your geotechnical engineering, and let's go for the introductory part of that geotech. So first part here, we say, what is soil? So what is soil here? So soil, I would say it's a material. Let's say that it's a material, and it's having some solid particles. The solid particles here, we can say those are your soil solid particles. They are formed from disintegration of rocks, from disintegration of rocks, disintegration of rocks. And I would say there would be some voids also. There would be some uh, what you can say voids. Voids would be there. Spaces would be there. That I would say the voids in between those solid particles, between those solid particles. Now we have options. It can be occupied by either we can say there might be air, there might be air, there might be water, or we can have both of these. We can have both of these between in the white spaces of those solid particles. So that is your soil material, soil. After that we have soil mechanics, soil mechanics, soil mechanics. So this term was given by Carl Terzaghi in 1925. So this guy, this is the father, we can say this is the father of your soil mechanics. This is the father of soil mechanics or geotechnical engineering, we can say. So your soil mechanics, it's defined as, we say this is the application. This is the application of laws of mechanics. Laws of mechanics. We have laws of mechanics, and we have hydraulics, and the laws of hydraulics. They are to be applied. Those laws of mechanics and hydraulics are to be applied for the engineering application of soil. In the engineering application of soil, application of soil. So we say that it means that we are talking about the action of forces. We are going to study the action of forces on the soil, action of forces on soil, and the moment of fluid, or we can moment of water, moment of water, moment of water inside that soil, moment of water inside that soil, inside the soil, or you can say through the soil. So this is the what we have soil mechanics. Here we say what is the we are talking about the action of forces on the soil and the moment of the water flow, the water inside the soil, through the soil. After that, we have one more part that we call as one more term that we have soil engineering. Soil engineering. So this is somewhat similar to that of that soil mechanics. That's application of that those concepts in the soil engineering properties of the soil. And after that, we have one more that we have a broader term that we call as geotechnical engineering. Geotechnical engineering. So this is a broader term we have. This is a broader term that we use in everyday life. That is broader term. Broader term. It includes soil engineering. It includes soil engineering, and we have also that rock mechanics here also, rock mechanics, and geology and geology. After that, we would say how this soil is going to form, how this soil is going to be formed. So that we have origin of soil. We say what is the origin of soil, how this soil is going to be originating, how this soil is going to be originating. So this is the origin of soil. To get the origin of soil, we have a concept that we have geological cycle, geological cycle, geological cycle. We say this cycle, uh, it's having three phases, three dominant phases. One is your what you call as erosion. One is your erosion. Second one is that transportation. One is your transportation and deposition. Transportation and deposition. Transportation and deposition. Third one is that moment of earth. Moment of earth. Moment of earth. Now, I would say there are three phases, so I can have a cycle. Let's have a cycle. There we have first phase, that's erosion. After that we have what you call as transportation and deposition. After that we have earth movement. So that's your geological cycle. Okay. Now, if we talk about that erosion, first part, that's erosion. If we talk about the first part, that's erosion. So what's erosion? What's erosion? We say erosion means that degradation of rocks. It's the degradation of rocks because of weathering. Because of weathering. So when we have weathering, there we have rocks degraded, so that it can be either physically or it can be chemically. So if we say we have first kind of weathering, that's physical weathering. So what's happening here? We say that the action of the wind, there is action of wind, there can be water also, there can be glaciers, so these kinds of physical agents, they are going to act on that rock, and I would say that there won't be, and the resultant of those action of wind, water, glaciers on the rocks, when they act on the rocks, what is going to happen? The resultant material that is going to form, resultant material, resultant particles, we can say resultant particles, they are there because it is a physical phenomena. So the chemical configuration or chemical constituents of that particle would be same as that of a parent material. So resultant particles would have same chemical formulae. That means they retain that chemical composition, we can say, chemical formula composition we can write as that of a parent material, as that of their originating, as that of their origin, so of that parent material. Okay. So this is what you have. This is the physical weathering, and I would say because of this we have kind of the particles that form, they are bulky in nature. The particles formed, they are bulky in nature. Particles formed. So that bulky nature, we can say, it can be, say, we can have a sand, we can have gravel, also. Sand, gravel, we can have boulders, we can have cobbles. So these are the names. For us, we are studying that sand and gravel. Okay, sand and gravel. So this is because you can see a sand particle. So this is, or you can take a gravel particle, one of the grains. So we call it as single grain arrangement. So the particle is formed here that we call as single grain arrangement. So the system that gets developed here, these particles, we call it as single grain arrangement. Okay. So final is here that because of the physical weathering, we have these agents, wind, water, glaciers, and there is also freezing and thawing of the material. And because of that, the resultant particles retain their chemical composition as that of a parent material. And because it's a physical phenomenon, the particles formed here are bulky in nature, like that of sand, gravel, and they are also, we call it as single grain arrangement. After that, we have second kind of weathering, that we have chemical weathering. We have second kind of weathering that we can say that is chemical weathering. We can write chemical weathering. Okay. Now, as the name suggests, there might be change in the chemical composition. Now, if your material rock, if your parent rock material is that, parent rock material is that, it's having some material, it's having some chemicals like that of a, it's having some acids inside, or alkalis, or it can be having some carbon dioxide, it can be having some oxygen also. So if the material, if the parent rock material is having these of the, one of these, any of these, or combination of these, when they react with water, when they react with water, what's going to happen? React with water. So your chemical reaction is going to start. Because of that reaction, because of that chemical reaction, your resulting materials, would be having the chemical composition different from the parent material. Resulting particles composition, chemical composition is different now, is going to change, is different now. And the particles here formed are, we call them as mineral clay, mineral, we can write clay mineral. The particles formed here, we name them as clay mineral. Particles formed because of chemical weathering, because of chemical weathering. So the particles formed because of chemical weathering, we call them as clay mineral. And here the size of the particles is less. Size of the particles is less. So here the size of the particles is less. Size of the particles is less. Size of the particles is less as compared to that of a single grain arrangement that we have sand and we have gravel. So here we have this clay mineral. Okay, clay mineral we have, and these are mostly we have shape of plate-like shape, plate-like assembly, plate-like shape is there, plate-like structures. The clay particles are having some plate-like structures. In this way, you can say, if you zoom that, I would say the particles have plate-like structures. Okay. Now, if I talk about now second part, second phase, erosion is over. Now, if I talk about transportation and deposition, transportation and deposition, transportation and deposition, transportation and deposition, and deposition. So when there is erosion of that material, now it's going to be transported. It's going to be transported. Now for that we have some agents, so what we call as transporting agents. So there are some agents that we can call that those are transporting agents. And here we can also say there we can have either we can have wind, we can have water, we can have glaciers, we can have glaciers. Okay, these are the few dominant agents: water, wind, ice. This is glacier ice. Now see, once there is erosion of the material, now because now there will be transportation, and when there is transportation, there might be that change in the structure of the material, change in the structure, change in the shape, change in the character of the material. So the character of the particle is influenced by the transporting agent. So based on the agent, your particle is going to be influenced. Your character of the particle is going to be influenced. So I can write that character of the particle, character of the particle that's going to be formed, character of soil particles. What do I mean by that? Character means that we are talking about the size, we are talking about the shape, we are talking about that surface texture of that material, surface texture. We are talking about the roundness of that material. Okay, we're talking about the shortings of that material, that size, etc. So this is a character of the soil particles. So this is influenced by the the agent we have, influenced by the transporting agent. It is influenced by the transporting agents. So this is your character of the soil particles. Okay. Now based on this, what you call as transporting agent, we can name the soils accordingly. We can name the soils accordingly based on the transporting agent. If I take that first one, that's river transported soils. If I say that there is water in the rivers and the soil formed because of that, we can say that's river transported soils, or soils. We can also call it as deposits. We also call it as deposits, soils or deposits. Let's talk about that. Water transported soils, that's also river in terms of river, we can also say this is water transported soils. Usually the main what we have force main reason for the transportation of because of water is the river transported soils. Now, so as there is water, so water can have either velocity less or it can have more velocity. Based on the velocity, your material is going to be transported. So our transportation, as the name suggests, that is we are going to transport something. So it is a function of velocity of the water. So if the velocity of the water is more, that means it has that capability, it has the potential to carry bigger particles also. It has the capability, it can carry that heavy, we can write here bigger particles. Bigger particles means it can carry boulders, cobbles. It can carry these bigger particles, okay. But if the velocity is less, that means it's going to deposit those. So if the velocity of the water is more, it's going to carry those boulders along with that. If you've seen some floods, it can carry bigger particles also along with that if the velocity was more in case of floods. But if the velocity is less, now it's going to deposit those bigger particles somewhere. So because of that, I would say there is deposition of those boulders at a particular location because the velocity is lesser. And similarly that when velocity goes on decreasing, your particle size that it can carry is also going to decrease. That means now only finer particles are going to be carried. Finer particles like sand, clay, finer particles are going to be carried now. If the velocity is going to be decreased, your finer particles are only going to be carried by along with the water, along with that water body, along with that river. Okay. So finally, if there is velocity coming to be approaching to zero, that's near the deltas, we call it as near the delta, that's delta is going to be formed. So velocity is actually zero, almost to zero, near the confluence, near the meeting point of that body, near the meeting point of a river body with the lake, or it can be with the sea also. River body meeting what you call as some other body. It can be meets a lake. It can meet some other stuff like that of a sea, ocean. So these things at the confluence of that, there we have a kind of delta that gets formed. So at that location, near the location of delta, we have finer particles, finer soil particles accumulated, because the soil, because the river is the velocity having zero, so it's not able to carry the particles along with it now. So if I make that diagram, if I make a picture of that, let's say this was your elevation. Here we have some mountains. I can say there we have some that parent rock is there. At the mountains there is some parent rock. Now because there is movement of water, and we are going to say there we have some ocean at the bottom here. Ocean is there. Ocean here is there. And along the traverse, along the path, somewhere we have our velocity was such that then now your boulders are going to be placed here. Boulders, cobbles, boulders are going to be placed here somewhere. After that, we are going to have gravels. Of lesser diameter, lesser size. There we have gravels here. After that, we have soil. I would say sand. Now sand is going to be placed because the velocity is less now. There we have sand. After that, we are going to have clay. Clay going to be deposited. This is deposition of those materials. Deposition. Now we are having the clay. So this is the configuration. Then we have finally delta. So it's having finer particles of clay. So that is the that what you call as that is the traverse of that river transported soils. Okay, river transported soils. Second one is that if you talk about the wind, if you talk about wind, so that name suggests if there is wind, so I would say wind transported soils. So here also we can say that if the wind velocity is much, if the wind velocity is high, so your finer particles, I would say, if you have more finer particles, they can be carried further, more distances with the wind. So the wind can carry finer particles to a larger, to a far distance, I can say. Finer particles are carried far away, from its origin, far away. See, if you talk about that dune sands, or you can say that sandstorm, you might have seen sandstorm. So in that case, you can have those example of that transportation of that wind, transportation of that sandy soil from one place to other. So that's your wind transported soils. And one more point is here that one more kind of soil is there that we have loess. We call it as loess. So this is actually, this is wind transported silt. Wind transported silt. We will be saying, we will be talking about the silt, what that silt is. So let's write that for now. Wind transported silt is there, that we call as loess, and it's also because of the wind. So let's have that glacier deposited soils. We might be also having that glacier transported soil, or we can say deposited soil, glacier transported soils. So what's glacier? I would say this is a bigger mass of ice. This is some ice. It's formed because of that snow compaction. When the snow is going to compact, it's formed at that hard solid mass of that ice. So that's your glacier. Now when there's melting, if there's melting or any other reason is there, if the glacier starts to move, if that rock, if that solid ice mass going to move, it would carry the material that's below it. It's going to carry the rocks below it. It may be rocks, it may be soil also. So it's going to carry that particular material along with it. So melting, there is movement. When it's going to move, when the glacier is going to move, it would carry what? It would carry that material material along with it. What material? That we can say solid parent material. This is your parent material. So once there is moment of that, so that means there is transportation of that, some sort of soil is going to be deposited somewhere, and we have a general term that we call it as a drift. So glacial drift. That means the drift is a term used for the soils formed. These are the soils formed because of glacier transported, because of the transportation caused by the glaciers. So these are the soils formed by the glaciers. We say this is, it can be directly formed or it can be indirectly. So this is your general term for the soils formed by glaciers. This is a general term. Now, if I want to go to the specific term, there's one more specific term that we call as till. This is specific. That is directly we are getting this soil from because of the directly we are getting this soil because of the glacial movement. Because of the glaciers, we are getting this soil. Soil directly we got the soil directly because of the glaciers. This we call it as a till. Okay. And one more possibility is there. We might be having soils formed because of gravity. So gravity transported soils. Gravity transported soils. Here the name suggested that because there is gravity, so there would be some movement of the material because of gravity. So let's talk about the rock fall. Do you know that rock falls, or there might be slides, landslides, etc. So there might be slides of that solid soil masses. Soil masses are going to slide because under the action of gravity. Rock falls under the action of gravity. Then after that they are coming. Let's talk about they are coming to the toe of that particular cliff or mountain. Toe of that particular cliff or mountain. Now the soil that is going to form with the passage of time, the soil formed with the passage of time at that location, that we call it as the soil former, that we call it as a talus, or we can also call it as colloidal soil. Colloidal soils. Colloidal soil. And that's we can say this is the end of that transportation. And if we talk about a little bit about the deposition, so we have different kinds of deposits. If we talk about deposits, that means some material is going to be placed somewhere. So that is deposition of that material, which was going first under erosion. After that, there is transportation of that material. Now it's going to be deposited somewhere. So based on the agent of the transportation, we have different names. First one is there. We call it as alluvial deposit, alluvial deposit, alluvial deposit. I can name that. I can name it in this way that uh, this deposit is formed because of the motion of the water. That's river water. Because of the river water. Because of the river water. Okay. Now one more here can be. It can be one more we can take. That's lacustrine, 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 lacustrine deposit. So these are the clay soil deposits. These are the soil deposits. Here deposit means that this is soil. So these soils are formed because of that still water. If there is still water, that is we can say there is lakes. Because of the lakes, the deposits formed are lacustrine deposits, lacustrine soils. There might be also that we call it as aeolian soils, aeolian deposits. Also we can write. Aeolian deposits means those soils, those sandy soils formed because of the wind, because of the action of wind, because of transportation of wind. So that's because of the wind. So this is the cause why these are happening. This is the cause because of these. Okay, it can be also marine clays, marine deposits. We can write marine deposits. If you go to the marine near the sea lines, sea coast lines, so you can have these. We call it as marine clays also because of it can be seas or it can be oceans. We can write here the cause for these. Okay. Also we can write glacial deposits, glacial deposits. So name suggests that because of glaciers, because of transport movement of glaciers, because of movement of glaciers. Now, if I talk about the final part of this lecture, that's regional soil deposits in India, regional soil deposits in India. So we have different kinds of soil deposits that are formed in India. First one is that alluvial deposits, alluvial deposits. So these kind of deposits are formed because of the action of rivers. So we have the movement of the rivers we have on the north side of India, because there is rivers on the north side of river India. They are originating from the north side of India, because we have mountains on the north side. So after that, the deposits they are in that North India, we can say the deposits of that soil in the northern India, North India, like that of we can have in the Punjab, Delhi, UP, we can say Kashmir, etc. Okay, so this is your North India. So the soil deposits here we have alluvial deposits, and they are having a particular character that we have alternate layers. We have alternate layers of clay, slit, and sand. So this is the character of those alluvial soils, alluvial deposits, that we have alternate layers of clay, slit, and sand. Clay, slit, and sand. Clay, slit, and sand. Okay. Sand, slit, clay. So after that, second one is there that we have second one case that we can write black cotton soils. Black cotton soil. So then here the name is saying that there's cotton. So these soils would be better for growing that cotton. So cotton is going to be yield. So cotton yield is going to be better in these soils. But as per the perspective of the engineering, so these are not suitable for engineering works. So you cannot have a construction on these soils. They are I would say they are present in somewhere in the central part of the India, central part, and some South India also. So this is your black cotton soils, and they are formed because of they are formed from residual deposits. These are the residual deposits from the rock. Its parent rock is the basalt rock, from the basalt rock, parent rock or basalt. Basalt, or we also have sometimes that trap rocks. And these, why they are suitable for cotton? Because they are having some chemical that's called as montmorillonite. Let's try that. They are having some clay mineral that we call as montmorillonite. So this montmorillonite is, because of this one, we are having that weak, I would say we are having weak character for engineering material, weak character as an engineering material. Because of this chemical mineral montmorillonite, where our soil, black cotton soil, is not good for engineering works. It's not good for engineering works. So we are going to see it why. What's the character here? So because of that, we are having some these bad character for the engineering works. We are going to see that later case. Okay, this is your black cotton soil. The soil, one more kind of deposit we can have. We can have that. Let's talk about that. We might be also having laterite deposits. Laterite deposits. So these deposits, the soils are having composition of that. Soil is having it. They might be having some iron oxides. They might be having aluminum oxides. And because of these oxides, their color is also some sort of pink brown color, pink red, some sort of color is there, red pink color soils. They are also formed from that residual deposits. They are also residual deposits formed from basalt rock. But they are having this chemical, what you call as these oxides. They are having these oxides present in them. Because of that, we have this color of red brown. Okay, and one more is there in the region of Rajasthan. We have desert soils, sand dunes. We can name them. The soils, sand dunes are the soils, sandy soils. And finally, we can write the marine clays. We can write marine deposits. So these are along the coastline of that India. Along the coastline, we have these marine clays. They are soft and plastic. They are very soft and they are plastic, highly plastic. So this plastic, we are going to see what this plastic means. So this is your end for the that introductory class for your soils, geotechnical engineering. And final touch we can have, if we talk about finally that different types of soils. So these kinds of soils we are going to touch during the course of that geotechnical engineering. So we can have a list of those. Let's talk about those soil types. We can have soil names. That means different types of soils we are talking about. So let's talk about that. Let's talk about the different names, different types of soils we have. Let's try that. First one is that simple clay. Clay can be there, silt can be there, gravel can be there, sand can be there, cobbles can be there, boulders. After that we have hard pans, we have humus, we have marl, we have morum, we have caliche, we have different names. Let's see that. We have peat, we have bentonite, bentonite clay, bentonite is there, loess is there, indurated clay, Warwood clays. Okay, we might be having that dune sand dunes. We are having till, we are having tundra, we are having tuff, we are having extra. So these the reason here we are not touching the what the system is all about, because they are associated with some terms. Those are the terms which would be which we are going to study in those subsequent chapters. So better is to understand these soils at the end of the content. So just you can have the names, and all of those we can touch during the span of the course. Okay, I would be saying that this is the end of the introductory part of the class, introductory geotechnical engineering. Thank you would be the best word to say. Thank you for watching. Okay.